Hello and welcome back. Today I have an HP test oscillator and it is the 652A and it goes from 10 Hz all the way up to 10 MHz. And HP started building these end 60s, early 70s. I have an idea this is a little bit of a later model. I would think early 80s. And it has to do with the switch in the back for the different voltages. And I have no clue if it's working. It looks that it has been a little bit in moisture because the aluminium doesn't look that good anymore. But we're just going to see if it works. 652A test oscillator bij Hewlett Packard. Elektronische instrumentatie. This is Dutch. So apparently this was the company that delivered it. It can go from times 10, from 10 Hz all the way to 100 here. And this doesn't work anymore, but it should rotate this. But you can see it's all moisture, but we can still turn the big one. So maybe if I mount it different, or this rubber ring is completely gone, that's probably the reasons. But we can do that times 100, times 1000, 10,000, 100 and a meg. So that means we can go up to 10 megahertz. I'm not sure if it's a square or a sine, but I would think it's a sine. We can set some references. I would not know why. We can do amplitude. I think it can go up to 3 volts, 3 and a bit. So I remember reading something like plus 23 dB on 50 ohms. And well, here we have the voltages. So let's have a look in the back. Well, I mentioned that the moisture, yeah, here you can see, and some screws are a little bit rusty. So I hope it still works. And here it is. And what made me think that it was maybe a little bit newer, something I read in the manual that at some point this switching over moved with a little switch here, and there was a note, and it started in 79 up to 82. So this could be a little bit of a later model. All you see, instead of this PH163, they connected the plug directly. It is switched to 230. So let's see. Well, the equipment was really built to last in that time. Like these handles, it is with a spring, so it comes back. Here you can also see some moisture, but really built to last. We're going to have a look inside, of course, also later. Now I'm just wondering if it works. I will already switch on the oscilloscope so we can see. Let's do it with 50 ohms. So, and well, let's set it to 0 dB. Start with 100 Hz. Let's plug it in. I hope I'm not going into the dark. No? Okay. Here we go. Yeah, the meter did something. And I think it's all transistor already. I see here the voltage, but okay. So within this setting, you apparently can do a little bit also, and this is the fine tune. Okay. Does it output something? Okay, I think we can see both. I will put the output of the 50 ohms. I put it here on my... Oh wow, that looks very smooth. and it says it is 9738, so it's almost 100. Can I fine tune a little bit? It almost gets to 100. What does this do? No, it does very little. We are now at 98. Maybe it's still heating. Cool. Okay, let's have a better look at that. Here we go. I think you can see the values. And well, I can start adjusting a little bit. It looks very clean, I must say. And well, let's do higher. Boom. Now we are at 1 megahertz, 1 kilohertz, 1 kilohertz, 10 kilohertz. Yes, 10, a little bit high, but we can probably get it exactly where we want. Oh, it adjusts very nice. Okay, 10, 100. Still looks very nice. Let's heat up the I'm also wondering about the harmonics, if it is very clean or not. So let's get also the spectrum analyzer. Meanwhile, and let's go some higher. It should be 10 megahertz. Yes, it is. Can I adjust that a little bit? Okay, let's put it from one to the other. This one is 50 ohms, so here I don't need any. Let's see if we can see the signal. Auto tune it. Yes, here we have a signal. Maybe if I go a little bit wider, we get like 200. Yeah, we see the one here, but there is a better way to do this. Let's see, measure harmonics. Here we go. Look at it. So compared, the second one is 36 minus, then 60, then 90. So it's only the second. Okay, we have some suppression. Okay, this is the 5 megahertz, and I'm looking here at this minus 284, and it should be exactly 0. So let's have a look at the analog scale there. So we have the scale here. I put it exactly in the center to 0. Oh wait, it is the RMS scale. Let me zoom in. This is an RMS scale. If I look at the 50 ohm in dBs, then I should use this one, and the 0 is here. So let me try to get it in. Okay, now let's see on the spectrum analyzer. No, look at that, look at that, it is 0.05 dBm. No, after so many years, it is still spot on. After so many years that it is so good still, and the output is very well calibrated. 0 dB is really 0 dB. I was amazed by that. And of course the frequency was a little bit off, but it is because you just turn this wheel and the fine tune doesn't work, because I think the rubber just that needs to touch the aluminium, or it is just running a little bit tough. So maybe if we grease it a little bit, it will be better. And Yeah, the harmonics were also not that bad. I think in that time, if it is minus 36 dB for the first coming harmonic, I don't think that's bad. And well, now we need to look inside. Well, it's probably smart to disconnect the power first. And well, usually my circuit breaker blows in old equipment, and it's usually the earth leakage. But this time, no. But maybe the one that put this plug also changed already the net filters, so there is no problem. I think there is only 2 screws on the top. Let's see. I wonder what is inside. I remember from the other HP, I don't remember the number, but it was a generator from 1.8 up to 4.5 gigahertz. That one had a glycerin oscillator. But I had a very quick look in the manual, and I saw transistors only. So hopefully we can see something. Okay, quick look. Oh, it's almost empty. Wow, look at those caps. There. Wow. This looks good. And the inside actually looks a lot better than the outside. So, a little bit closer. Look at that. Yeah, this looks still amazing. This cap, and I don't see any problems. So maybe we just need to grease this a little bit. This is the frequency switch. Each switch has its own cap to adjust the frequency. And well, this may be the amplifier that controls the output. I'm not touching this because it was spot on. And here we have the attenuator. And well, then the oscillator is probably here on the bottom, because here I see the output. Little coax going in here. Let's turn it around. Okay, let's turn it. Oh, look at that. All the feet are still here. That is also very unique. All here. Unbelievable. Usually these are the first things that get lost. This one is not put in correctly. Alright. That's a pity why they did that. Delicate force. Here we go. Here we have the flatness adjustment. It looked nice. We even have a 1 kc distortion, and we have a 10 MHz adjust right there. So here we have a better look. The 1 kc distortion adjust, the 10 MHz adjust. Well, I'm not touching it. It looked good. And well, power supply probably, not sure. And the line filter right here. But I'm amazed how good this air cap looks. It is like new. How can it look so bad from the outside and then brand new on the inside? Yeah, and the line filter, I guess that it is replaced, or they just cut out all these capacitors because it didn't blow any of my fuses. So what did I do here? Okay, they put with tape. Oh, they put it directly on the connector. So if you put your fingers in the in the 163, you will blow it. But the caps are still there. Okay, so there is still filtering there. I'm always surprised how mechanically good these look with all these little wheels. They're very nicely done. And here is some sort of spring that needs to push to the, that's why it doesn't work, the fine tune. Look, that is, it is supposed to be a spring that pushes the fine tune to the big scale. And yeah, you can see it just here on the top. This is the spring, and this is the fine tune here. So if I push it, now it is away from the scale, and this spring should actually push it back against the scale, and then this is the fine tune. But this is not smooth at all. So no way the spring can push that this hard. So that means this little axle we need to grease a little bit. So I put it now up aside, and here we can see, a bit back, here we can see this is the fine tune, and that is this little axle here, and that should be pushed by this spring, but it is not going anywhere. So that probably needs some cleaning. Well, I have, of course, my WD-40. I can use that here, and I can just spray that in between, and then let's see if we can get this moving again. I don't need to worry too much about this because there is no electric circuit here. This is purely mechanical. So let's see if I have the correct W40. Yeah, this is the, not the contact cleaner, but the oil. So not too much. And then try to move it. Yeah, it almost goes. You can see it's already pushing it back now, but still slow, but at least it is working now. So after a good cleaning, it all looks a lot better. And because I used a little bit of WD-40, I can now use the fine tune again. Perfect. Yeah, almost like new. And it's almost 50 years old. So the old HP652A, and it was still working. The frequency was not that far off, but also what can you expect if you just have a dial like this? And the output level was perfect. 0 dB was 0 dB. And I did see a little harmonic on the 10 megahertz, I think 35 dB, so that's not that bad. And I am surprised it doesn't have an external reference input, because it is a test generator, and HP is very professional, but maybe in that time, or it was an option that this one doesn't have. But yeah, amazing, it's still working, some good quality. Thank you for watching, and hope to see you next time.